because today is our last day of the workshop. So we are having some validity session. So we have to start the early session. After this session, there is another session. Experts will be there. Okay, so that's why you start early. Okay, thank you. Shobik, please carry on.
Am I audible?
Yes, you are audible. Start your presentation. Yes.
So, good afternoon to all. Myself Souvik Mondal, PhD Research Scholar, Department of Electrical Engineering, National Institute of Technology, Rourkela. Today, I am presenting my work, design and simulation of zero voltage switching converter, means resonant converter. In the introduction session, we can cover the resonant converter, that is a DC to DC or DC to AC type uh, power converter, transfer energy, minimum switching losses. The resonant converters operate by shaping the voltage and current waveform to achieve soft switching conditions such as zero voltage switching and zero current switching. So here we are covered only zero voltage switching converters. So zero voltage switching, when the switch turns on at zero voltage and ZCS is zero current, so switch off. And the next we are going to types of resonant converter. We are covered that. The types of resonant converter, mainly two types. One is series resonant, one is parallel resonance. And series resonant parallel resonant converter, and another is LLC converter. Why we use zero voltage switching converters? So zero voltage switching converter mainly having the reducing switching loss. In the conventional converter, the switch MOSFET and IGBT, when we use, the then turns on and off when the both voltage and currents are present. So that's why higher switching losses are there. In ZVS converter turns on when the voltage across nearly to zero. So the switching losses are reduced, then improve efficiency. When lower switching losses means the heat dissipation is lower. Heat dissipation is also there, but in other converter, heat dissipation is uh, heat dissipation is means higher, so that the switching losses is also much higher. Electromagnetic interference also minimize electromagnetic interference. In that case, smooth voltage and current transition reduce high frequency noise and EMI, improving performance and reliability. Then enable high frequency operation. Switching losses and electromagnetic interference are reduced in Z-based converter, safely operate higher switching frequency. Z-based converter decreases the size of passive component like inductor and capacitor to enhance device reliability, reduce stress on semiconductors, switching during longer device life, and uh, better thermal performance. In difference, the hard switching and soft switching. Here we can see that the hard switching condition, the power loss is there. In other cases, the soft switching techniques, the power losses is almost near to zero, almost near to zero. So in that case, the soft switching techniques also used in our methods and in our microgrid applications, and also EV charging applications also we use in soft switching techniques like ZBase and ZCS. Hard switching, in that case, transistor, I previously told that when that both voltage are present, then the hard switching is there. But the VI overlap is also cause significant switching losses. Significant switching losses. In that case, the soft switching cases, transistor on single cases. The lower EMI installation, previously I told that. The main principle is that ZVS converter, this resonant tank, dead time, and voltage clamping lossless turns on. The in next slide, you please can check that our one resonant converter is there. We do that. In hardware setup, we not currently done, but we are going for that. In PCB also we done. In PCB designing also we done. So commonly ZVS topology, we are using that. This is resonant LLC. precipitate full bridge, and also one quasi-resonant circuit. Main the design configuration is that resonant tank design, load range, dead time management control, and component selection. In the resonant tank, the LNR value is critical, but in LNR value also we can select the lower. Sorry. And the dead time must be precisely controlled. It must be long and enough for the resonant to bring the VDS to zero. Drain to source voltage of MOSFET and is zero, nearly to zero, cause extra conduction loss. Yes, we can go. Main the design configuration of the ZBS converter. Here we can use the duty ratio also. This is the ZBS buck converter we use here. Here we can see that LR and CR is the resonant inductance and resonant capacitance. Also there, two diodes we are using there, D1 and D2. And the duty ratio is the D is equal to V out by V in. These formulas we can calculate the ZVS buck converter design and calculation of our ZVS buck converter design. Output current also I out is equal to P power output by output voltage. Load resistance also R load is equal to output voltage by current. Ripple current also IL is equal to K into at K is nearly 20 to 40% we are using. Mm, Output voltage also we know that B into D and inductance also. Here the PCB implementation in our case. We designed the PCB in MATLAB simulation. After that the results we can design the PCB in KiCad software. KiCad software after the PCB layout we just fitted all the essential components. I have not here write that the components was set up. The in these heatsink cases, two switches are there. Two switches are and diode is one switches and diode is there. After the component here we can selecting our components. After then the other method is also not completed yet, so I can show my only PCB implementation design in it can do. So JDBS we used mainly in data centers, electric vehicle charging cases, onboard and high voltage DC-DC converters, renewable energy, solar inverter, battery charger, where maximum efficiency is critical. ZBS resonant inverter is standard in that case. ZBS we use that in cases means switching mode power supplies also we can use to achieve when we achieve achieve the ZBS properly, the load current must be sufficient to charge and discharge the switch parasitic capacitance. The resonant converter must store energy to cause zero voltage transition. Switching time must be carefully controlled in that when we use the ZBS converter. ZBS also sequence also operation ZBS operation also there's when switch key one is on and off. In that case, ZBS also operating. Thank you so much. Any question is there? Sir, are you there?
Hello. Yes, we are there.
Okay, ma'am.
So, any question regarding this topic? Anybody can arise their questions. Hello, am I audible? Hello.
So the next part will continue. Mainak Biswas. Thank you. Mainak, are you able to hear me?
Yes, yes.
Thank you. Please continue.
So, I am sharing my screen. So, screen is visible. Anybody please respond.
Yes, yes, it's visible.
Okay. So, today we are discussing about the remaining part for the C2000 microcontroller. And yesterday, actually, I left. That's why. So, let's start about the rest of the things about the C2000 microcontroller. Okay. So here we can see like we'll discuss about the bidirectional DC-DC converter, like that is control using the C2000 microcontroller. The microcontroller name model name is F28379D, and we'll cover like hello. We'll cover like closed loop control with PID and charging and discharging operation. Okay. So we'll cover the objective like implement a closed loop bidirectional DC-DC converter, that is BDC, using the TI C2000 microcontroller, and after that we'll see the control battery charging and discharging through the PWM signals, and we'll maintain the stable uh, battery voltage and using the real-time PID control. And after that, we'll use the ADC feedback, that is the analog to digital, and the GPIO-based mode, the general purpose input and output mode selection. Uh, then in the hardware and software setup, we'll cover the areas like for the hardware, the TI launchpad, like whatever we have discussed yesterday or day before yesterday, like 2538379D, and the DC source and the battery and the MOSFETs and the inductors. Okay, and for the software part, we'll see in the Code Composer Studio, that is CCS, and for my case, I am using the version 11, and the control suite. One second. sorry for interrupt, for the control suite and the C2000 oil libraries. Okay, and then we'll just connect the C2000 with the GPIO pins. For my project, I will use the GPIO 12 for the mode of switching, like zero for charging and one for discharging. Okay, and the ADC A0, that is the battery voltage, that is VWAT for the battery voltage, and the ADC A1 for the battery current, that is IBAT. Okay, and the EPWM1, this is for charging the switch, charging switch, and EPWM2 for the discharging switch. That's it. Okay, and I will just show the setup part in the CCS software. But before that, I am discussing about the topics. This is the just a small discussion. Okay, and then I will just show in CCS software also. Okay. So in C2000 software, that is the steps basically. Just note down the steps because the steps are very much difficult to search in Google. Like I just covered all the parts, including the setup part also in C2000. Okay, so just if possible, just copy the parts. Okay, like. First, open the Code Composer Studio and then select the target launchpad. In my case, that is the launchpad number. So then we'll load the proper GL file. In my case, the GL file named like F2837 into D dot GL. And for the CPU and CPU1 and CPU2, we already know about the C2000 microcontroller and the launchpad. This is comes with two CPU like CPU1 and CPU2, and then we'll import the project like select F2837D underscore device. It will come with the support files, and will include then the F2837D underscore the global variable DFS the dot C. That is a linker software, and it will link with the command file. Okay. But in my case, in my PC, that specific soft part like F2 837 into D global variables. In my case, that is missing in my PC. That's why I have downloaded it from the GitHub. You can download it also. And after that, I will build the project, and and it will resolve the library paths. Okay. Then I will connect the target. For my case, that is the CPU1 first. You can use the CPU2 also. Then you will load the program and the run in debug mode. Okay. So after completion the run, then you will observe the EPWM and the ADC signals using the CCS graph, and you will watch the window also. Okay. So this is the system initialization, like it will initialize the system control like clocks, PLL, watchdog, etc. Then it initializes the PIE vector table, and is interrupt the controller. Okay. Then we'll configure the GPIO pins for the general purpose input output pins for the for mode input and debug LEDs. Okay, so that C2000 microcontroller comes with the built-in LEDs, so we can use that one. Okay, so no need to carry the external LEDs. Okay, so then initialize the PWM and the ADC peripherals like the pulse width modulation and acid analog to digital peripherals. Then it will enable the ADC interrupt for the control loop execution. Okay. Then we'll cover the PWM and ADC configuration, like here the EPWM1 for the control charging mode for battery. This is DC bus, battery or DC bus. You can use any of them. And for the EPWM2, for the here we are using for the control discharging mode. Then the PWM frequency, in my case, that is the 20 kilowatts, and date time is 50. And ADC channels A1 for A0 for battery voltage and A1 for battery current. Okay, and ADC triggered by the PWM, that is synchronous sampling. For PID control, interrupt service routine, that is called as ISR also. What is that? Basically, that is it will trigger by the ADC conversion completion, and it reads the VBAT and the IBAT. For feedback, one is voltage and current. Then it will determine the reference voltage based on the mode. Like in my case, that is minus 48 volt for charging and 52 volt for discharging, and it will calculate the PID output, like adjust the PWM duty, and that duty is clamped between 0 to 0.9. Okay, and update the previous error, and it will clear the interrupt flags. And after that, the control logic summary, that is a very simple, like charging, that mode is set to 0, and EPWM1 for active, and that is EPWM2 for disable, that is on and off basically, nothing else. And for discharging mode, for mode 1, and EPWM2 for the active, and EPWM1 for the disable, means it is off. Okay, and for PID, that ensures that stable transition and maintains reference voltages. And after that, the closed loop feedback ensures the robust converter performance. Then, so how to debug and verification in Code Composer Studio for C2000 microcontroller? We'll use some extension or the graphs window to monitor the VWAT, the for voltage, and IWAT for current, and the duty ratio and the errors. Okay, so we'll use the breakpoints in control uh, to step through the PID updates, and we'll check the EPWM for waveforms using an oscilloscope. Then it will verify the transition between the charge and discharge mode via GPIO switch. GPIO is nothing but the general purpose input and output, and it will observe the system stability under the varying load or voltage conditions. So with this, we'll conclude that, like it will successfully implemented in the real time BDC control on TIC 2000 platform, and it is a dual mode operation achieved by that using the GPU controlled logic and the PID control stabilized bus, and battery voltages effectively. Like it demonstrates the efficient use of ADC, analog to digital converter, the PWM, pulse width modulation, and the interrupt based control. And after that, it will be ready for the execution. Will apply in the microgrid or energy storage systems. Okay, so this is the basically the theory part, but I will discuss in CCS software also. That is CCS software. That version is 11.0.0. In my case, you can use another version also. For my case, that 11 version is I have downloaded from the TI website. Then for a new project, you will just just create one project. In my case, the project name is BDC underscore C2000 test underscore test. And when you create the project, it will automatically create some files, like includes, debug, target configurations, like that. Okay, then it will automatically just create one main.c file. That is the main programming file for that specifics project. So you just write the code here. Okay, so here we are just discussing about the code. Before that, I will show how to set up the C2000 software with the prerequisite things. Like if you click on the software project, like in my case that is BDC underscore C2000 underscore test. If you right click on it and go to properties, uh, it will show that, one second. In general, you see the device name, that is family is C2000, variant and code. In my case, that already selected, but here is not showing. Like you will just see 2837 into D, that is the Delfino series. Okay, and the version is TMS TMS 320F28379. That is for in my project we are using one also. And the any compatible code, like you can use the CPU 1 or CPU 2. You can use any of this. For my case, I'm using the CPU 1. And for the connection, you will select the Texas Instrument XDS 100 version 2 underscore USB debug probe for that. And if that is not working, then you will select the another one. Okay. Then you have to select the version 2 or version 3 or normal, that Texas Instruments XDS 110 USB debug probe, any of the three. Okay. For my case, the version 2 USB debug probe is working. So then after that, click on the verify. It will verify in the screen, and it is showing that that is a successfully verifying. Okay, that is success. And after that, I will select on finish. Then it will compiler version automatically selected, and then just nothing else. Then just click on apply and close. Then you just check the include options. What is the include option basically? I'm just showing, like in my case, the first line is the code, this include option. There's the include is, that is the library basically. There's a set of code like f28x underscore project.h that include just commenting, like includes device header and system definitions. For that you have to select the include file. Okay, how to select the include file? The path is already has been defined here, like the in my case that is C, then TI, then C2000, then C2000 OIR. The OIR version is 4.0.0. Then the device support. Then we'll select the processor name or the launchpad name, like F2837 into D. Then go to common and include. That's it. Sorry. So if you just click on add and browse, that will select from that path. You will select that one, that one, that one, that all, whatever you are selecting, that should be defined in the include option. Okay. Then normally just go to apply and close. The process is done. Okay. Then you will just write the code. Write the code. In my case, the code is basically for I think 190 lines total. Okay. So in your case, the code may be different. Code size may be different. Okay. Okay. So once again, I am just going to discuss about the code and how the code is working, and why that code is written basically. Okay, what is the purpose? One second. Okay, so that code is basically for the closed loop control system for the bidirectional DC to DC converter, that is BDC, using the C2000, our Texas Instruments launchpad. And it supports the both charging and discharging mode for DC battery bus system, and it will automatically controlling the power flow using the PWM ADC and the PID control. Okay, the PID control algorithm. Okay, so for the first one is the include option. That is the include option. Basically, that is the library. We are just calling the library. That is the basic C programming, nothing else. Just modified the C programming, and this is library, the set of code. And for that we will just configure some of the things, like we'll define the PWM frequency, define the date time, define the V reference charge, then the V reference discharge, those parameters basically. And after that, we'll just call the parameters inside the code and get the outputs. Okay, so for my case, that is the PWM frequency is 20 hertz, then the date time is 50, then the V reference charging is 48, for discharging is that is 52. I already mentioned in my slides. Okay, then the PWM PID coefficients, like we'll define the KP, KI, KD values as very most important. The PIDs coefficients. Then the device, define the device. Okay, so that is for the for my case, that is 200 millihertz for the launch pad, basically the in my selected launch pad. Then the we'll select the global variables, that is basically the float, that is basically V bat for voltage, I bat for current, then error, then duty, then unit 16 for the mode, that is 0 for charging and 1 for discharging, nothing else. Okay, then the function prototypes, it is a void, and we'll initialize the PWM, EPWM. That one is EPWM, then ADC, then GPIO, then we'll read the ADC, we'll set the PWM duty, like that only. Then that is the main function for the code, like there's the inside the main, we'll just initialize the portion whatever we have defined here, that is the and here we are just throwing one loop, that is a while loop, just the GPU data, and that is 0 for charging and 1 for discharging. That is basically just run into the loop. We are for here we are using the while loop also. Okay, then the initialize GPIO for whatever the pins for the GPIO, that is the for C2000 microcontroller, that is a switch input for 0, and that is a debug LED, that is 1. That is for GPIO 12, that is the C2000 microcontroller pin, and the GPIO 0, that is also the C2000 microcontroller pin, that is for the debug LED. Okay, then same we are just initialize the EPWM, then the EPWM charging mode, the values are defined here. Okay, so like that only, just see the code, and those are the 190 lines code only. Then after writing the code, you will just click on this hammer icon, that is the for build. So it will just show the any lines of code is mistake, like that will be the syntactical mistakes, that will be the logical mistakes also. So you'll just click on the build option, and that will show see, just finish building. Wait for some seconds, that is 64% is completed till now. Wait for some time, it is building. That is a warning basically. Some of the lines of code, I think that is giving the showing the warnings, but the build is finished, there is no error. Okay, so 0 error, the 108 warnings, so you can just find out the lines and you will just rectify the code. Okay, but there is no error. Then so there is no error, I am just click on run, and just click on the F11 for the debug, that will debug the code and upload to the hardware. Okay, so it will just launching, and I will select the both CPU, like CPU1 and CPU2. It will just change it, like in your case only CPU1 has been used, but my case I am just for demo purpose I am using CPU1 and CPU2 also for the code deployment. Okay, and that will take some time, and here will in console will show, you will see that the code has been deployed successfully. Okay, if there is no error, just see. It's loading. It is building in CPU 1. Then after that, you will also it's the same thing will build in CPU 2 also, but it's not necessary for building the both CPUs. But for demo purpose, I am showing that like the two CPUs are all available to build the code. You can select any of them. Or for the parallel processing, you can select both the CPUs like CPU 1 and CPU 2. That's not a problem. It will take some time. Just wait and see. Now it is in CPU 2. I've already connected my C2000 with my PC. It's taking time, like 84% is done. Okay, it's done. It's already done, and CPU2 is complete in CPU2 and CPU1. Okay, so there is no error. That's why it is building successfully. If there is error, then it will just told you to like debug the code or errors. Okay, just you will rectify the error. Then again the same process will happen. Okay, then this is the stop or terminate option. I will terminate the building, then it will come to with this same interface. Okay, so here I have building some dedicated PPTs for the code deployment. How to deploy the code. I will just share the PPT. For step one, open the CCS and create a new project. Then launch the project, launch the Code Composer Studio. It is CCS 11. I already told that one. And select a workspace. Like you can select your workspace. Like for my case, that is CCS underscore workspace. And then we'll just that is the bidirectional converter project. That is for the BDC underscore project. Then you will just simply go to file and new, then create on CCS project and set the project name like you will take your name from your own and then select that device. For my case, my device name is this, and just do the connection. For connection, you will just select the Texas Instruments XDS 100 V2 USB debug probe, then select the language C, then finish. It will automatically create the prerequisite libraries. Okay, then add the source code to the project. Like in Project Explorer, click on SRC and then new, then source file. Then name it file name should be main.c. If not, then you can just write the name main.c, then paste your controller code, like in my case that is the bidirectional controller code, then save the file. Then after that I will configure the build settings. For build settings I already shown, like right click on the project and the properties to go to general, then device and confirm the particular board for particular launchpad. Like in my case that board name is this, and set the compiler version, that is the TI version 20.2.4 LTS. That I think that is automatically selected, and then click on the apply and OK. For build the project, I already shown, like click on the hammer icon, then go to the project and build project, then go to the CCS compiles and the source files, and it will generate the a dot out file. Okay, when I just click on the hammer icon, it will generate one dot out file. Okay, then click on the console output, and console output it will show that the build finished successfully. So the next step is the will connect the launchpad. I already connected my launchpad, C2000 launchpad. That number is this via USB, and then ensure the power LED is on. That is the built-in LED in C2000 microcontroller. Uh, then CCS should detect the Texas Instrument XDS 100V2 automatically. Then verify the connection. I already shown you the how to verify the connection using the view target configurations. Then 1 second. Then debug and load to the target. Click on the bug icon or press 11 for CCS. The CCS will build the project. If that is the modified, uh, whatever the code you have written that is correct, then connect the MCU, then load the .out file and the flash the RAM, flash into the RAM, and the CCS will automatically switches to debug and perspective, and it will run and monitor the execution. It will click on resume to start the code execution, then view the expressions. Those are the things, and it will variables to monitor like VWAS, VBAT, duty, charging mode, etc. Whatever the thing we have to define here, so those things we have to show in the variable to the monitors. Okay, and it will observe the real-time variable updates like the serial monitors. And to stop or terminate the debug session, click on the suspend like pause button from the execution. Uh, Click on the terminate to stop and return to the edit perspective. And you will just rebuild or modify the code, and it will reload anytime. Okay. So summary of code development, which is 11.0, that is the summary basically I have already discussed. So that's it for CCS code development. Uh, I think I have covered the code development part for CCS Code Composer Studio using C2000, and last day I already shown the code development using the MATLAB. So I think that part is clear to you. So that's it for my side now. So uh, any questions regarding that? You can just unmute and ask your questions. Hello, am I audible?
You're audible, but actually, I'm going to use that C2000 after a few days. So maybe questions will come afterwards.
Okay, just see the recorded video. It will available in YouTube. Just
Now, one
Yes,
maybe silly question. Maybe silly question because I have not gone through all the video you are showing the PPT yesterday because I was busy with some other work. So I have frequently not showing. My question is actually this controller you have chosen. What is the specialty of the controller over? Is it the signal processing also doing, or the only the controller is controlling the exit
No, no.
static
Yes,
part of
yes.
the controlling?
Then no, that not the static part only. It will the dynamic part also. The C2000 microcontroller comes with the two CPUs. Okay, that is a dual core CPU, and you can just in my project.
Simultaneously you can control and receive both the part
Yes.
you are doing.
Yes, that is the main thing in this C2000 microcontroller basically. So in CPU 1 and CPU 2, the both are present in C2000 in this particular version, and you can just go through the CPU 1 and CPU 2 for the parallel processing also. That is the
Okay,
main.
that is it. It is a kind of in Raspberry Pi also this kind of
No, no,
there
no.
are 4 core.
The
But
Raspberry
what
Pi
is
is Raspberry Pi is a single board computer. That is not the microcontroller actually.
no,
So
not microcontroller, but it has
yes,
4 CPU that you are talking about CPU. That is why I am telling.
yes.
They
The Raspberry
it
Pi is different thing. That is a single board computer. That is comes with the Wi-Fi and Bluetooth also. But in C2000 microcontroller, that is microcontroller with the two CPUs like CPU one and CPU two. Okay, for the parallel processing, you are just using that CPU one and CPU two. Both are the CPUs, and if you want to use one CPU, that is also fine.
okay,
That is
but
that your
CPU1
project
but the
purpose you can use
controlling
it.
part I am asking that it is the
Uh-huh.
dynamic controlling means real time controlling, or it is the controlling option is you have put it as in
No, no,
program.
no. Obviously, the real-time controlling you can do.
We can do, but here
and
it is there in your real time, or it is the controlling that you are depending on the closed loop normal controlling.
So both are present. Closed
Oh,
loop normal
here
controls both are present. Yes,
okay, okay,
yes.
okay,
For
so
my
now
case, I am just
what
showing it for the demo purpose. Okay. Last day in with the MATLAB, I have shown like two sensors are available, like the EDN sensor and the temperature sensor. Okay. That time we are just capturing the value in real time also. Okay. If
okay.
possible,
So
you can
one
this
just
one
see
C2
the videos.
this C200 is not under MATLAB like hardware in loop. It is just a actual controller you are using.
Yes.
Okay, okay.
Just C2, not
see
C200, not C200 actually.
Triple
C2000.
zero, triple zero.
Yes.
Okay, and
Yes.
Wi-Fi, Bluetooth, and other things are also there.
No. Wi-Fi,
Only
Bluetooth, not
controller. Okay,
only controller. For Wi-Fi, Bluetooth, you can use
so
Raspberry Pi, but there is some limitations, and C2000 also have some limitations.
like
one more thing I want to ask. CPU1 means plant and CPU2 will be controller. Is it like that?
Can you please ask again?
CPU1 will be plant and CPU2 will be
No,
controller.
no, no,
Is it
no,
like that?
no, no, no. Both are same. You can use both of the CPU. In case you are using CPU1, that will also fine. But if you want to use CPU2 for the same purpose, that is also fine. Okay. And if you want
Why
to
both
use
are required?
CPU1 and CPU2 parallelly, that is also possible.
Why both are required then CPU1, CPU?
Both are not required. Actually, that is for the project purpose. If your project purpose you need to use the CPU1, that is also fine. And if you want to use the CPU2, that is also fine. And if you want to use the CPU1 and CPU2 parallelly, that is also available in C2000 in this microcontrollers launchpad.
okay. So
Means
in this
two
case, what
student
is
they
your
can work.
target? What is your
One by one,
target
please.
to
One
do
by one,
this in
please.
this project?
Sorry.
In this project, what is your target to do?
That is not a project. That is the simple thing. The bidirectional converter I have just shown. The simple.
Okay,
Just I am just coded and how to deploy it. I am just share how to deploy to the C2000 software. You can use your own
okay,
project. You
okay.
can own
I
code.
have understood now. Now
Yes.
the thing is that means your controller is doing work from the DC output where you are deploying in the load. In between that, you are showing that it is the bidirectional. If it is required, where to place it in the bidirectional converter. It
Yes.
is between battery and load
No.
or DC
That
bus
is
and load.
you are use if you are using like a C2000, if you're
Uh,
using as a gate driver circuit, okay, if
okay,
you can use it,
okay,
okay. For the gate
okay.
bus, you can also use the C2000 microcontroller. That is not a problem. But
As it is bidirectional converter, so that means if it is battery even, so converter is here bidirectional converter means here you are either feeding to load or your load may
that
be
is
battery.
basically the requirement that as per your requirement you can use it. That is the thing. Like I have whatever I have discussed, that is the one purpose, one project purpose. Okay. if you are using that one in your project purpose, that should be different. Okay.
Okay. But your project, I am asking that where you have actually used it.
We are using in many things. Okay, like for gate driver, we are used so the same the C2000 microcontroller for the pulse. Okay, we are using the parallel processing like some real-time sensors. We have used it. We have used.
Okay.
In many cases, we have used it.
Okay.
For
But
your
in not
purpose
that
only.
bidirectional, you are not using in every
No,
case.
no, that is the main, the normal, the code. This normal is a
Okay.
code. Okay, I'm just showing the is for testing purpose only.
Okay. Okay. Now I
Okay,
have
understood.
understood. Yes.
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 Everything clear,
Thank you.
right?
No, yes. Yes. Thank you.
Okay. Okay. Any questions?
Sir, there
I
is a
think
question.
yes.
Sir,
Okay.
sir,
Sure.
actually, we are using C2000 as a microcontroller.
Hmm.
So will be in what the program you have written. In that there is a small statements. Those statements are compulsory. It has to be mentioned only in that particular format or any other format also you can mention, sir.
What statement?
Actually, we are writing some coding for C using C program itself. So pin numbers and all we are giving. That is like a PWM input signal and output signal where it has to enter and where it has to leave through which pin we are entering through program. Isn't it, sir?
Yes. For my case, I am using that C2000 launchpad. The number I have already mentioned. Okay, for my case, the pin diagram is different. Okay, for if you are using the another C2000, another version of C2000 launchpad, the pin number should be different. As per your launchpad, you can just define your pin numbers.
Your own.
Okay, sir.
In any microcontroller, you have the right, you decide which pin supposed to do what.
Yes.
Yeah.
Yes, sir.
Same for the we have used previously we are using the Arduino microcontroller, the Atmega Uno Atmega 328P. That code that pin number should be different. That is a different thing, but I'm just telling for the example. For your microcontroller, you have to define your own pin numbers.
Thank
the
you,
pin
sir.
number may be different, right?
Thank you, sir.
Yes. Anything else?
Mainak.
Yes, sir.
Okay, so I think your session almost complete. Am I right?
Okay, yes, almost completed. Just question answering.
Okay. So if there are any doubt, please let us know.
I think, sir, no more questions.
Okay.
Okay.
Okay, then I'm trying to communicate other expert. So then within some time we can able to start the session, another session. Okay. Wait for me.